Hello there. I'm redoing this braking system on the bottom, and there really wasn't much I could do up here at the top. And the reason is that anything above this point, actually this point here, there's a bracket that fits in the back, and as this rotates, it has to have clearance. That's why this is circular here, and then you notice the cutout here because of the bracket. That's the strap that moves it 0 to 90. The bracket holds the strap, and that's the clearance for the strap, and it can't be any bigger than this. And I had that aluminum bar I put on here. That was an upgrade to that 3D printed one I made, and the aluminum bar worked pretty good. I mean, it clamped down on this side, and then it clamped down on this side at the same time, but it's supposed to clamp down on one side all the way, but you never can be sure of that, and you don't know if you're going to get a little bit of movement in there. You don't need much movement, you just need a little bit, and next thing you know, it starts chattering and this and that. And I really wanted to upgrade that system, and I thought that was the best upgrade I could do was when I put that aluminum piece on there. But if you remember that I had this piece on top, and that's so when the unit rotated, the plastic that I had was getting caught on these corners. The plastic, these weren't even there, and it was square, and the plastic was getting caught on these corners. So I put this piece on there and one on the other side, and then I mounted this piece on there so the plastic would ride on the circular piece and there'd be no corners. That's like when you're patching up a RC airplane, you use a circular patch, because if you use a square patch, it would peel up in the corner, but if you use the circular patch, it wouldn't peel up because there's no corners. So that's basically the same principle as this, is circular, so that the plastic would ride on this piece and not get caught in the corners. So that was the purpose of this piece. And the more I look at this piece, if you notice, it almost looks like a disc brake. And I started thinking about that, and I says, instead of this being used to keep the plastic from getting caught, I could use that as a disc brake, and that would be a substantial upgrade to this piece I had here. If I mounted something here that would clamp that, and something on this side that would clamp that, holy mackerel, that would isolate that and wouldn't give it any freedom of movement at all. So let me put you up here. But this is it's a spacer. It goes from here up to here, and there's a piece that fits inside of here. It's like it's got a circular piece on this side and a square piece on this side with a hole in the middle, and it's the same thing on this side. Then this piece would be the the disc. Well, let me pause you while I get the parts. Okay, I got the parts. Now this is a spacer. See, right now this piece and this piece are flat. So the bottom of the disc would be even with the bottom of this piece. So what happens here is this piece mounts inside of there, and then this piece, which would be the disc, would mount there, and this piece, which is the spacer, would mount there, and then this piece which is the upper part of the caliper, I guess you would call it, would mount there. Now that would be the same for both sides. So when you activate the brake, it clamps this piece against here and against here. So what you say, what activates it? Well, you remember the cylinder I had on both sides of here. There's one in the front, one in the back. There's 4 of them. One over here. It's that long looking thing, had the circular thing on top where the piston was. So anyway, what it does is, I'll take this off. I'll move this aside without trying to knock it over. Okay. So this piece is on top, and I got these little arms on both sides. See these arms? Now there's a slot in here I know it's hard to see because it's now this is the cutout for that piece that houses the bearing, and this is the cutout for that circular piece for the axle. So these little arms are in there, and there's a spring that goes in there. Remember the original spring I used for through here to keep those two things apart? Well, I'm using the same spring, and what happens is that the piston is mounted on the outside just like before, and then it pushes against this arm. See that arm there? It pushes against that arm, and it raises this piece here. See how it raises it up a little bit? Now it does that on both sides. So when the piston is activated, it pushes onto there. And it raises both of those up at the same time. Like that. And then the spring keeps it down. So when this raises up, that raises up against the bottom of this disc, and then this piece is on the top, so it captures that disc between this piece and this piece, and it locks it solid. So you got this piece that's mounted onto here, and that's mounted with a couple of straps on the outside and a couple of bolts on the inside, so that's solidly locked to that block, and then the other one is locked. So then when this piece gets raised up on both sides and it clamps on this piece, that's going to lock that top unit up tight. So that's the new idea, and I think it's a lot better than what I had here. Of course, I wouldn't be doing it if I didn't think it was better. I don't want to make the unit worse. I want to make it better. So that's what we're doing now, since we got it apart. So that's what these pieces are that I showed you before. Now, of course, I made this out of Delrin because I wanted to see if it worked or not. And I'm going to get them made out of metal or aluminum, but the guy that I'm getting it made from, I asked him several weeks ago about getting these parts made, and he never answered me back. I don't know why he's not talking to me. I've only dealt with him for a couple of years, but this is a little shaft. This is what it looks like. This shaft goes through there, and I got this thread on here. That's what locks it in place. There's a hole that goes through there. That fits in there like that. Yeah, I couldn't put a bolt or anything in there, so I just took a little piece of threaded rod and turned the diameter here to fit that. That's 3/16. Then I just used that thread just to thread it in the back, and I put a little slot in it with a hacksaw, and I just threads in there and holds it in place. Acts as a little pivot point for this. Same thing. It's all four of them are the same way. So that's what I'm going with. Now what I did here was I put a chamfer. Well, I used a 90-degree countersink, and I went down there so I had a very little land at the bottom, so that I didn't want to keep it. I needed this tight. I mean, it's a tight fit. It's almost a dowel pin fit. It practically is a dowel pin fit. But I needed this to be able to move, because if one side moves up more than the other side, you know, I need some degree of freedom in there. So by countersinking this, it leaves me a very thin land so that it has the ability to move and still be tight, still lock it in place. So it can orbit around and still hold position. So that's so anyway, I made these out of Delrin just to see if they'd fit. They're not really strong enough for what I want, and you know, I talked to the laser guy, sent him an email a couple weeks ago, almost 3 weeks ago, and he never answered me back. I sent him another one, and I guess I'm gonna have to send him out somewhere else to get them done. I don't know what the deal is with that guy. But anyway, yeah, that's the story behind these. So we'll see how this works out. Yeah, these straps are gonna help hold it down, and this is the piece that goes on the side over here. This is the so it's gonna fit in there like that. This get bolted through here, and then there's 2 bolts here that come in from the bottom of here, one here and one over here on the bottom. The bottom here and the bottom here, they get bolted in from the bottom, which should be right here. So that's the latest and the greatest. All right. Bye.